So now we are going to understand how to find out equivalent capacitance between A and B in this circuit. Now we have set of capacitors here. So they are connected in series and parallel, but we are not sure which capacitors are connected in series or which are in parallel. So we are going to use here connection removal method, as we have discussed in the resistance method also. Now we are going to study the connection removal method in this case also. So in connection removal method, what we are going to do in this case, as we know that if you look at this circuit carefully, if suppose I current will flow from here, some amount of current will go up, some amount of current will go there, right? But you see that during this path, this connection, suppose I1 current is going here, I2 current is going there, right? Now I2 will go up and has to come back here again. But whenever I1 current is flowing in this branch, so what is going to happen? It will not cross this path. If it will go there, then current will be confused where to go now, right? So now I1 has to go straight and I2 has to go up to the upper path, right? Upper part. Now what we are going to say that we are going to remove this connection, like this connection will be removed from here. There is no such connection between this branch and this branch, right? So now what will be the equivalent circuit for this? Let's see this once. These are our A and B point. This is how it will look like. This connection will be removed, right? Is this clear to everyone? Now, let's find out the total capacitance in this case. As we know that whenever we study about the resistance, we will say that resistance is in parallel, so we generally add it R1 plus R2. If it is in series, R1 plus R2. If it is in parallel, 1 by R1 plus 1 by R2 is equal to 1 by R equivalent. Or we can use it R1 R2 divided by R1 plus R2. But in the case of capacitance, it is totally opposite. In the case of capacitance, whenever it is in series, so we generally say that it is 1 by C equivalent is equal to 1 by C1 plus 1 by C2, right? Now, see carefully. Shall I solve this part first? These two are connected how? It's end-to-end connection, they're series. So if all the capacitor having C capacitance, so these two are in series because it is end-to-end connected. So what is the equivalent capacitance because of this 2? C by 2. Now this C by 2 and C are in parallel. Can I say that this one and this entire circuit, this is C by 2 and this is C, they are in parallel. In parallel, we know that what will happen? It will get added. So it will become 3C by 2. Now I'm just giving you one more picture. Let's see it once again. Here we have one, right? In between, two capacitors are there. This is my A point and this is my B point. We can also verify this. Here we have C and this will become 3C by 2. This is C, these are 2C, right? Is this clear? C, C, C here and 3C by 2. Now we can see that these three are connected in a series or parallel. Series, it is end-to-end connection, so we'll say that it is in series. So because of these three, what is the equivalence? Can I say that because of these three? In series, we know that whenever we are finding the net capacitance, we'll say that 1 by C equivalent is equal to, what is this? 1 by C plus 1 by 3C by 2 plus 1 by C. Now if we take LCM, how much it will become? 3C. This will become 3 plus 2 plus 3. How much it will become? 8 by 3C, right? So this C equivalence will become 3C by 8. So now this will become 3C by 8, right? Now what will be the equivalent circuit now? These two are in series again. So what is the equivalence because of those two? C by 2. Now let's make the final circuit now. We have upper one's capacitance, lower one capacitance. This is the point A, this is the point B, right? Now what is this capacitor now? 3C by 8. And what is this capacitance now? C by 2. Now you tell me, are they connected in series or parallel? If they are in parallel, so how will find out total capacitance? It will get added. So this total capacitance C final will become 3C by 8 plus C by 2. Now again we have to take the LCM. How much is the LCM? 8. 3C plus 4C. 7C by 8. This is our answer. Understood? This is our answer. Now let's have a quick summary. We are saying this current will not flow from there. Current as it is will go here. This is I1. This is my I2 current. So connection will end. This is called connection removal method. So when connection will end, we will see these two are in series. Series will become C by 2. And that is in parallel with C capacitance. Then total will become, you can say that C by 2 plus C. This will become 3C by 2, right? This will become 3C by 2. Now, the equivalent circuit will become C here, C, 3C by 2 and C. Then again these three are in series. So net it will become 3C by 8 because we know that whenever it is in series, so 1 by C equivalent is equal to 1 by C, 1 by C1, 1 by C2 plus 1 by C3. Same after doing this, we'll get the 3C by 8. Then equivalent circuit will be 3C by 8 and C by 2. And those two are in parallel because we can see the starting point and ending point are same. We will say that it is in parallel connection. So it will get added. So total answer will be 7C by 8. Now, read the question again. If the equivalent capacitance between A and B, we have to find out the equivalent capacitance between A and B. Each capacitance is 2 microfarad. So what is our final answer? 7 by 8 C. C value is given there. Can you tell me the correct answer now? Yes or no? So what is the correct answer according to this? 1 point. So this is the correct answer. And shall I tell you about the specialty of this question? This question came in P value of J. Okay. Is this clear? Any doubt? Okay. You can match the answer now. Let's match the answer. Our answer is 1.75. As we have seen it, this is 7 by 8 C. And we know that C is equal to 2 microfarad. So it will become 14 by 8. Let's solve it further. 7 by 4. How much it is? 1.75 microfarad. This is the connection removal method. Understood? Is this clear? Now, any doubt? Any doubt from here? Ask me now.
Why did the current split into two parts when it entered the circuit?
Why current split into two parts? Very good. Now, you see it case, whenever the current is starting from one side, these two connections are divided into two parts. We know that whenever it is a series, just like we studied in before also, whenever it is, my capacitance is like this, same wire is going on that time, the current is flowing in series, it will be the same. But whenever it is splitting into two, that means it is clearly indicating that these two are in parallel. Whenever parallel connection you will see, the current will split it. Okay, it's just like you have one wire here, half of the current you divided here, half you divided here. It's not always the half, you can divide some part of the current here, some part of the here if you are connecting with two points. Okay, understood? Anyone else?
In the case of resistance, the resistance get added when they are in series, but in the case of capacitance, they are reverse. Why?
Okay, in the case of series, I'll show you here. In the case of resistance, we have like this. R. We generally say that R equivalent is equal to R1 plus R2. How we are saying it? We are saying that in this case, potentials total potential will be calculated as V1 plus V2, right? In the case of resistance, we generally say that V1 is equal to, in series case, I current is there. So let's take it is R1, R2. Okay, so V1 will become what? I R1, I R2, right? And what is V? I R equivalent, right? So I value will be same because it is a series connection, right? I is same. That's what we are saying, right? So R equivalent is equal to R1 plus R2. Now, if you see this in case of capacitor, let's see this once again. If you see in case of capacitance, right? Now, in this capacitor, suppose it is connected to a battery, right? Suppose it is connected to a battery and battery having potential V. Now, in this battery, I will say that some charge Q will be there. Suppose Q1 here, Q2 here. Okay. Now, we know that again this is series connection. Series means what? We generally say that current is same, right? Series means current is same. But in the case of capacitor, we are not studying anything regarding the current, right? But we are studying the charge. Current and charge are related to each other, right? So in this series connection, we are talking about charge. Total charge will be same. Yes or no? Total charge same, right? Clear? Whatever the charge stored will be there, that is Q1, Q2, both will be same equal to Q. Is this clear? Any doubt? No. So what will be the difference? Again same. V is equal to V1 plus V2, just like we did in the resistors. So what is V? We have studied one formula in the last class. Q is equal to CV. So V is equal to what? Q by C. Now what is V here? Q by C equivalent. What is V1 here? Q1 by C1, Q2 by C2, right? And we are saying this in the case of series connection. Q1, Q2 are same. So can I say that Q is equal to Q1 plus Q2, right? Oh, sorry. Q is equal to Q1 is equal to Q2. So all will get cancelled, right? So what will you get? 1 by C equivalent is equal to 1 by C1, 1 by C2. That's how it will come. Just like in the case of resistance, we are saying current same. Now we are going to tell that it is charge same. Okay. And same concept, potential difference will be different for the both of the capacitor, right? That's how we are finding the current. Understood? Is this clear? Anyone else?
In the case of resistance, if we have two wires with one with resistance and one without resistance, the current will follow the path without resistance. So in capacitance, do I have the same case?
See, remember only one thing. Whenever you are solving any circuit problem, remember that if we have one wire or if we have one wire with one resistance, both is having resistance. One is having wire resistance, another is having external resistance plus wire resistance. Current will follow that path in which it will face the less resistance. Right? It's just like, as I already told you, whenever we feel comfort, we go in the comfort direction, right? Similarly, current is also feeling same. Resistance is what? It's a restriction, right? It's a opposition, right? I will not let you flow from there, right? That is our resistance for the current. So, current will not follow that path if resistance is there. So, it will follow that path where less resistance will be experienced.